So here we have an original equation. Transformation-wise, can you see that the parent graph of the one that we're looking at is an x squared graph? That's a parabola. What's happened to that parabola? The negative flips it down, and then the 4 would move it up 4. So there's just a quick review of graphing. We had our original parent graph, the x squared graph, that would look like this. It gets flipped down and moved up 4. This is the graph that we're working with. Now we're going to determine the equation of the inverse of this. We're going to think, what happens when I reflect this over this line? What would that equation be? Notice again, it didn't say inverse function. Can you see that if you flip over that parabola, that you'll get a sideways parabola, and it won't be a function unless we take away part of the bottom. So algebraically, we start by switching the x and the y, just like we did before. Then we want to solve for y, so I'll move 4 over to the other side. I would have to multiply everything by a negative. And then square root both sides. And this is where you're going to forget things. You have to remember, when you square root both sides, you're going to have to add plus or minus. If you know that that's something that's going to be hard for you to remember, maybe you want to put into your calendar every night at 9:30 a little reminder. Right? And every night your phone buzzes and goes, remember to add the plus or minus when you square root both sides. You know, eventually you'd be like, oh, but you will never forget. If that happens to you every night for a month, you'll probably be like, yes, okay, I know this already. I can take that off my phone. Now graphically, if we would switch the x and the y. Here I have the point 0, 4. Can you see on my graph I would have the point, when I flip it, 4, 0. I don't know, this should go right through there, somewhere like that. 4, 0. And you're going to get, it's going to have to go through those 2 points. So that is our inverse relationship. Just to make a connection between what we were doing earlier, I could write this as 2 different equations. One of them would be where I use the plus sign, and one of them where I use the negative sign out in front. If we think about transformations, what does this negative do? Inside. Flips it over the y-axis. What does a plus 4 do? Moves it to the left 4. Does it look like it moved it to the left 4? It looks like it moved it to the right 4. Why is that? Another thing you have to put in your phone for 9:35, right? When you have a horizontal reflection, stretch, or compression with a horizontal translation, you have to factor it, which would make it negative x minus 4 and negative x minus 4. By the end of the year, it should work out that every 5 minutes from 9:30 till midnight, you'll get math reminders. I'm just kidding. So if this is your square root graph, your original one, and it gets flipped over the x-axis, that would end up like that, and then eventually it gets moved 4 to the right, you can see that that matches up nicely, perfectly, with that one. And all the second equation would do would provide, first you would flip it down, then it would get flipped over, and then get moved 1, 2, 3, 4, and match perfectly with the one on the okay. Match perfectly with the one on the bottom. So that's graphically. This question did not ask anything about the graphic stuff. I'm just using it as a way for you to help review a little bit of some of the stuff that we did before. So now we've sketched the original equation in blue and the inverse. We came up with the equation for the inverse. Is the inverse a function? No. Does not pass. Even though when we break it up, we could have two separate functions, because both of these ones, when I broke it up, are functions, but when it's all together, it's not a function. Okay, questions 5 and 6 are the ones you can do with that.